I'm going to go over free response question number 3 from the 2021 AP Calculus BC exam. I'm not going to read the whole question. I think you all can read that. I'm just going to jump right to part A. We have to find the area of the region in the first quadrant bounded by the x-axis and the graph of this function for c equals 6. So we have a picture here. So this is going to be a graph of y equals 6x times the square root. Let me bring the square root inside here. Square root of 4 minus x squared. So we have to find this area right here. And before we can do that, we have to be sure that we know what this point is right here. Well, the y-coordinate is pretty obviously 0, so if we have 0 equals this function, well, the zeros of this function are at -2 and 2 for in here, and 0 right here. This one isn't -2 or 0, so it has to be 2. So when we do our integral, we're going to be doing it from 0 to 2, and it's going to be of this function right here with respect to x. So we have 6x times the square root of 4 minus x squared dx. And since we have x squared in here and an x on the outside, that suggests that I do a u substitution. Let u equal to the inside of the square root here. So we'll say u equals 4 minus x squared. And this way, the du will be -2x dx. And I'm going to go ahead and divide the -2 on both sides. So I'll have -1/2 du equals x dx. That way I can substitute that in for this part right here. But let's go ahead and rewrite this integral in terms of u now. So this is going to be 6 integral. And don't forget, this was x going from 0 to 2. If we're doing u now, we have to be sure that we know what u will be going from. So if x starts at 0, we have to put 0 in right here. We have 4 minus 0 is 4. And u will be going, when x is 2, put in 2 right here. 4 minus 2 squared is 0. And then we have the square root. The 4 minus x squared right here is the u. And then the x dx is this right here, -1/2 du. So we'll say -1/2 du right here. All right, you'll notice one thing here. These limits are out of order. We like to start at the lower one, but I have this negative right here, so I can use that to flip the limits. So I can say that this is equal to, also we have 6 times 1/2, which is 3. So we have 3, and this is now positive, going from 0 to 4 of the square root of u du. And now we can go ahead and find an antiderivative. Let's just get a little more space here. Okay. So this is like u to the 1/2, add 1 to the power. We still have the 3 in the front. I'm going to add 1 to the power. We have u to the 3/2. Then I have to divide by the new power, so I'll multiply by 2/3. And I'm plugging in u going from 0 to 4. The 0 will cancel everything out, so I just have to plug in the 4. So I have 3 times 2/3 times 4 to the 3/2. And you do not have to simplify this at all. You can just stop right here and move on to part B. So we'll move on to part B here. Now part B is sort of the more difficult, less straightforward part of this question. We are known, so they gave us the first derivative here. They didn't have to do this, but they did. And we know that for a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. So basically what we're looking for right here is the maximum value of this function. Well, how can we do that? We can set the first derivative equal to 0 to find the critical values. So let's go ahead and do that. So I need 0 to equal our first derivative right here. So 0 equals c times 4 minus 2x squared over the square root of 4 minus x squared. All right, now we're setting something equal to 0, so I know that this denominator, we can't have the denominator equal to 0. The denominator also won't change whether the fraction is equal to 0, so I can get rid of that. And we know that c is a positive constant, so it can never be 0, so I'll cross that off. So all I have to do is set this part equal to 0. So I'll just do that really quickly. I'll add 2x squared to both sides. I have 2x squared equals to 4. Divide both sides by 2, take the square root. I have x equals plus or minus the square root of 2. Which is it? Is it positive or negative? Well, it has to be the positive one, because if you put negative radical 2 in here for x, you would see that c is positive, square root is always positive, so y would end up being negative if we put in negative radical 2. But as we can see by our graph here, y is always positive or 0. So it has to be the positive version, not the negative one. All right, so we know that we're going to be checking x equals the square root of 2. Now, if the largest cross-sectional circular slice is 1.2 inches, I know that my maximum value is 1.2, wherever that is. So basically what I'm doing is plugging in for this right here, the point radical 2, 1.2, and solving for c. So let me go ahead and clear off all this extra writing over here so that I have some room to do that. Oh, that's not an eraser. Let's try that again. All right, I'm going to get rid of all of this. All right, and let's take a look now. So we have 1.2 equals c times x, which is the square root of 2, times the square root of 4 minus x, which is again the square root of 2, squared. All right, let's simplify that. Actually, you know what? Let's not even simplify this. C is just going to be this over the... Oh, no. Yeah, C is going to be, if I divide this on both sides, this is going to be 1.2 over this right here. Square root of 2 times 4 minus radical 2 squared. Yeah, you don't have to simplify this. You can just leave it like this. This is our value of C. And let's move on to part C. So for part C, we're going to do a little bit of volume. It's relatively straightforward. All right, so we know that the volume of a spinning toy is 2 pi cubic inches. Well, how can we find the volume? Well, the volume is going to be pi times the integral of the radius, which is going to be y, squared, dx. This is just our volume formula. And we know that this has to equal 2 pi. So let's go ahead and firstly divide pi on both sides. And now let's plug in our y function, which is this right here. So, and again, this point right here is at 2, so this integral is going from 0 to 2. So we need the integral from 0 to 2. Here's our y function. We just have to square each part. So we square the c, we get c squared. That's a constant multiple. I'm going to take that to the outside. And then we have x. We're going to square that. We square the square root. We just get the inside, which is 4 minus x squared. And we need this to equal 2. All right, well, let's go ahead and expand the integrand here. So we know that c squared times the integral from 0 to 2. Distribute, I have 4x squared minus x to the 4th. Whoops, x to the 4th equals 2. Now let's go ahead and integrate. So I have c squared times integrating this, I'm going to get 4/3 x cubed minus 1/5 x to the 5th, and I have to plug in here 0 to 2, and this has to be equal to 2. Well, the zeros will all cancel because we just have power functions, and I'm trying to move this down if it lets me. So I just have to plug in 2. So c squared times 2 cubed is 8. 8 times 4 is 32. So I have 32/3 minus 2 to the 5th is 32, and then over 5. This has to equal 2. C is going to be, I can just divide this on both sides without simplifying anything and take the square root. So we'll say c squared still equals 2 over 32/3 minus 32/5. And then I will take the square root on both sides. So when I take the square root, I'll have c equals the square root right here. Do I need a plus or minus? No, I do not, because we know that c is a positive constant, so this is our value of c, and this is the end of problem number 3.